Hello everyone, I'm Chinmay from Computer Science Department. Today's my topic is about VHDL in structural modeling. Let's look into the topic. What is VHDL? VHDL is Very High Speed Integrated Circuit Hardware Description Language. It's a hardware description language used for describing the behavior and structure of electronic systems, especially digital circuits. It's used for FPGA and ASIC design and allows for simulation, synthesis, and verification of hardware systems. VHDL modeling types. There are three types of modeling. One is behavioral modeling, data flow modeling, and structural modeling. Behavioral modeling is nothing but it describes the function or behavior of a system. Data flow modeling describes how data flows between components. Structural modeling it describes the system by specifying how components are connected together. What is structural modeling in VHDL? In VHDL, structural modeling refers to describing a design in terms of its components and how these components are interconnected. It focuses on the architecture and interconnections of lower level components such as gates, flip-flops, and submodules to form a complete system. Structural models represent the netlist of a design where you define instances of components such as AND gates, registers, or other predefined modules and connect them together using signals. Let's look into the key elements of a structural model. First one is entity declaration. It describes the external interface of a model. It includes inputs and outputs which you will give to the program. And it also defines the ports, signals through which the module interacts with other components. Second is architecture body. It contains the internal structure of the module and it also includes how it made up of the other entity, how these entities are connected. It also includes how the program has to be uh, um, executed. Next is component declaration and instantiation. Component declaration, it describes the components. It's a reusable entity. Instantiation, it creates it creates the instances of the components in the architecture. Entity declaration. This is an example of a full adder. Here entity is a keyword. Full adder is the name of the entity where you will give any other name. Port is also a keyword for the input. A, B, C in are the input of a type STD logic. Sum and output are the output of a type STD logic. And full adder is the end which ends the full adder entity. Architecture with structural modeling. This is the architecture. This is the architecture of name structural of a full adder, which is the entity. Component X XOR 2 represent it's a two input XOR gate. Port includes A B input of type STD logic and Y output of type STD logic. And component ends the component signal keyword which represent S1 S2 are the intermediate signals which will store the value during the execution of the program. C1 and C2 are the carry signal which will hold the result during the addition part of the program. And here begin is a keyword. XOR 2 XOR 1 is the instance of the XOR 2 gate where mapping happens, where A, B are the input to the gate XOR A and B are the input to the XOR1 gate XOR gate, which stores the output in the S1 intermediate signal. XOR to the instance of the XOR2, where map represent S1 intermediate signal and Cin are the input to the XOR gate, which stores the output in the sum. Then this is the end structural, which shows the ending of the architecture structural. Let's look into the advantage of structural modeling. First one is modularity. It allows reuse of previously defined components, reducing the code repetition and increasing the maintainability. Second one is clarity and organization. It makes large designs more understandable by breaking them down to small components, managing the small manageable components. Third one is scalability. It's easier to scale a design as new components can be instantiated and interconnected. Fourth one is direct mapping to hardware. Structural VHDL model represents a direct translation of hardware where each VHDL component corresponds to a real hardware element like gate, flip-flop or bus. Let's look into the challenges in structural modeling. Complexity with large designs. As a design grows, the interconnection between the components increases, making the code more complex to manage. Second one is resource management. These structural designs require careful consideration of how components are instantiated as each component consumes hardware resources. Third one is reusability concerns. While structural models are modular, managing reused components across multiple projects can sometimes become challenging. Use cases and applications of structural modeling. ASIC and FPGA design. Structural modeling is commonly used in ASIC, application-specific integrated circuit, and FPGA, field programmable gate array designs, where the hardware is built from components like gates, registers, and multiplexers. Second one is digital circuit design. Structural VHDL is ideal for representing logic circuits where specific gates are used to achieve a required functionality. Third one is communication system. It is used for building communication circuits, filters, and encoding or decoding logic. And the last part is, structural VHDL is essential for building a complex digital systems by connecting predefined components. It provides modularity, clarity, and scalability, making it a valuable tool in hardware design. While it is straightforward for small design, managing large designs can become challenging without careful organization. That's all. This is all about VHDL modeling, VHDL in structural modeling. Thank you.